Hello everyone, I am Mrs. Sayyida Fahmina from Ahmad bin Majid Private School. This video is about topic 11, Alcohols, Objective 11.1c. Deduce the presence of CH3CHOH group in an alcohol from its reaction with alkaline aqueous iodine to form triiodomethane. This is also called Iodoform reaction. At the end of this video, learners should be able to deduce the presence of CH3CHOH group in an alcohol from its reaction with alkaline aqueous iodine to form triiodomethane. Learn some important terminologies, study the conditions necessary to proceed the above reaction, solve some questions. The chemistry of triiodomethane iodoform reaction. The triiodomethane iodoform reaction can be used to identify the presence of methyl group or methyl group directly connected to the COH, OH bearing carbon. A positive result. In case of positive result, the pale yellow precipitate of triiodomethane iodoform is given by an alcohol containing the group, this type of grouping. R can be hydrogen atom or a hydrocarbon group, for example an alkyl group. If R is hydrogen, then you have the primary alcohol ethanol. Ethanol is the only primary alcohol to give the triiodomethane iodoform reaction. If R is an hydrocarbon, then you have a secondary alcohol. Lots of secondary alcohols give this reaction, but those that do all have a methyl group attached to the carbon with the OH group. No tertiary alcohols can contain this group because no tertiary alcohols can have a hydrogen atom attached to the carbon with the OH group. No tertiary alcohol give the triiodomethane or iodoform reaction. Doing the triiodomethane iodoform reaction, there are two methods, or you can use two different types of reagent. Using iodine and sodium hydroxide solution, or using potassium iodide and sodium chlorate 1 solutions. Using iodine and sodium hydroxide solution, this is chemically the more obvious method. Iodine solution is added to a small amount of an alcohol, followed by just enough sodium hydroxide solution to remove the color of the iodine. If nothing happens in the cold, it may be necessary to warm the mixture very gently. A positive result is the appearance of a very pale yellow precipitate of triiodomethane, means you will get the cloudy solution of, and the color of the solution should be what? Yellow. Why it is pale yellow? Due to the formation of triiodomethane means one carbon, so triiodomethane, commonly called iodoform. Apart from its color, this can be recognized by its faintly medical smell. It is used as an antiseptic on the sort of sticky plasters you put on minor cuts, for example. Using potassium iodide and sodium chlorate 1 solution. Sodium chlorate 1 is also known as sodium hypochlorite. Potassium iodide solution is added to a small amount of an alcohol, followed by sodium chlorate solution. Again, if no precipitate is formed in the core, so it may be necessary to warm the mixture very gently. The positive result is the same, pale yellow precipitate of triiodomethane. Summary of the reaction during triiodomethane. By using alkaline iodine solution, what happened actually? This is methyl alcohol, the OH bearing carbon directly attached to the methyl group. The first step is showing oxidation by NaOI formed by the reaction between I2 and NaOH. We are using alkaline iodine solution. So alkaline means any alkali sodium hydroxide and iodine means I2. So they will form sodium iodoxide. So this compound will oxidize by sodium iodoxide and we will get CH3. This hydrogen will remove two hydrogens as it is oxidation, so removal of hydrogen, and we will get ketone carbonyl group. Then another step, substitution of hydrogen by reaction with I2 in the presence of OH minus. So here this hydrogen will be substituted by iodine, and the last step, the breaking of this bond happen and we will get triiodomethane and carboxylate salt. You can explain like this also. This is methyl alcohol, react with 4 moles of iodine and 6 moles of sodium hydroxide. We will get triiodomethane. We will get sodium, any salt of carboxylic acid with sodium depending on what compound or you are using here, then sodium iodide and water. The iodoform test is used also to distinguish between ethanol and methanol. This is ethanol. You have methyl group. If there is no methyl group, it means the test is negative. So here ethanol will give positive iodoform test because of the methyl group. But here methanol, due to the absence of methyl group, it cannot form triiodomethane. So there is no reaction, so negative iodoform test. You can also explain the reaction. Step 1 is, as I already discussed with you guys, oxidation step, and here we are getting carbonyl group. Then second one is halogenation. The methyl group 3 hydrogen will be substituted by 3 iodine, and the last step is hydrolysis. So here this bond will break in the presence of alkali and we will get iodoform reaction and salt. Visual identification. In case of negative result, you will get like this, and positive result means pale yellow precipitate, or you will get, now after some time the precipitate will settle down like this. So you will get positive result mean pale yellow precipitate of triiodomethane. Now let's try some questions based on the topic. How would you carry out the triiodomethane reaction on a sample of an alcohol? So you know that you need the reagent, and what reagent are necessary? We will add iodine solution followed by enough sodium hydroxide solution to remove the color of iodine. Then if the result will not happen, so we will warm the solution very gently and we will get the pale yellow precipitate of triiodomethane. Or you can use another one, add potassium iodide solution followed by sodium chlorate solution warm very gently if nothing happens in the cold, and in this case also the pale yellow precipitate will form. What would happen if you had a positive result? How you will identify the test is positive? Number 1, a pale yellow precipitate, and you can smell with a faintly antiseptic smell. See, what exactly does a positive result show about the alcohol? As you know that those alcohol will give positive result in which the methyl group is directly attached to the OH bearing carbon. Practice questions and answers. Further, number D, which of the following alcohols would give a positive triiodomethane? There are many alcohols. Number A, so what you will observe first? In A, you will see the most important thing is OH holding carbon. So here the OH holding carbon, left hand side is ethyl group or ethyl group, and right hand side is ethyl group. So there is no methyl directly attached. So for A, the result is negative. In case of B, both side is methyl group. So in this case, the result is positive. In case of C, the methyl group is also present, but it is not directly attached to the OH bearing carbon. So in case of C, the result is negative. In case of ethanol, the OH bearing carbon has methyl group. So in this case also positive. So B will give positive result, D will give positive result, and G will give positive result, but A, C, E, F and H, in these case the result is negative. And what is the reason? That the OH bearing carbon does not contain methyl group, and here the methyl group is there, but the problem is it is tertiary alcohol. Good luck. Thank you.